All right. So today I wanted to talk about some tricks for memorizing the derivatives of trigonometric functions. Maybe now you're learning the derivatives of trig functions, or you've learned them, but you're having a hard time memorizing them. And when they come up on the test, you're just hoping you don't see tangent or secant because you've only been able to memorize sine and cosine. That's fine. I felt the same way. The last four of these are pretty confusing, but hopefully after today, you can use this system to memorize these better. So let's go through these. First of all, the derivative of sine is cosine. The derivative of cosine is negative sine. That's why I say these are a little easier to memorize. They're just each other. Derivative of tangent is secant squared x. Derivative of cosecant is negative cosecant x cotangent x. Secant squared is secant x tangent x. Cotangent is negative cosecant squared x. Okay, so I wrote the two rules over here on the right that I think are really helpful for memorizing these. So if you've been looking at what I wrote over here and following along, you might have the answers to the first. If our function starts with the letter c, then the derivative is what? So if we look over here, c, the derivative of all of these are negative. So if our trig function starts with c, our derivative is negative. If it doesn't start with c, if it starts with s or with t, then the derivative is positive. Our second rule, which I think this one is a little more complicated and probably more helpful in terms of memorizing, because these last four are the hardest for us to memorize usually. The tangent and secant functions and the derivatives contain exactly two blank and one blank. Okay, what I mean by this, if you have a function, tangent, for example, if we think about tangent and its derivative, secant squared, I've got one tangent and two secants. Why are we thinking like this? We're not doing that with sine or with cosine. The reason is, if we continue looking at all of these, we can use this method to find our derivative very easily. If we continue, cosecant, I have one cosecant or secant, however to use the trick, we call it a secant. We have one cosecant, so we need another cosecant and a cotangent. So I have two secants or two cosecants in one tangent or cotangent. If we continue, we have a secant, we need two of those, so our derivative will contain one, and we need a tangent, so our derivative will contain the other tangent. And finally, cotangent, we would need the two cosecants to go with that. So the tangent and secant functions and their derivatives contain exactly two secants or cosecants. Oh, this is going behind my head, isn't it? All right. Well, oh well. Exactly two secants and one tangent or cotangent behind my head. Okay, no problem. So right now, when we're looking at all of this, it's like, is that so helpful? But if you were taking a test and it came up, what is the derivative of secant of x? Let's say d dx of secant of x. Then we can think, okay, I got a secant. I need two secants, one tangent. Two secants, one tangent. Okay, two secants. I've got one. I need another. Just write it down. And a tangent. Just write it down. Yeah, I think that's sort of it. That's the trick. I hope it helped.